Good morning. Let us start today's session on group technology, which is a very important concept to understand. Uh, Based on this concept, we'll be having another concept called as computer-aided process planning. So, let us see what is group technology. So, group technology is a theory of management based on the principle that similar things should be done similarly. So it is a common concept. It's a very common concept that whatever the things which are common, those things should be done commonly or similarly, or some common procedure must be followed to perform those things. It is the realization that many problems are similar and that by grouping the similar problem, a single solution can be found to a set of problems, thus saving time and effort. So it is quite logical that if there are similar problems exist and if we can have a common a common solution for those problems, so that will save our time and effort. So that is what GT realizes upon. One second. Okay. So GT is a group technology, is a manufacturing philosophy in which similar parts are identified and grouped together to take the advantage of their similarities in design and production. So whatever the two fundamentals or the two principles mentioned in the first 2 points, they said that common problems must have a common solution to save the time and effort, and some similar things must be performed similarly. That will be a quite logical solution. By using these two terminologies or two concepts or two theories, principles, uh, a manufacturing philosophy is identified or it is proposed that similar parts are identified and they are grouped together. They we can form a part family of those parts, and then we can have some common procedures to execute the fabrication of those parts. So what are those similarities, how those parts are grouped into part families depending upon their design and production similarities. Whatever the design and manufacturing production similarities based on that, the parts can be grouped together, grouped into part families. So that is overall concept of group technology. Let me add one more thing. Batch production is the most commonly used or most widely used method in manufacturing. So there are there is job production, there is mass production, and there is batch production. So batch production is the technique or is the procedure which is largely employed uh, when we talk of the any fabrication or production line. So that's why that particular system, batch production system, needs to be strengthened, needs to be make more efficient. So for that, we use the technology called as group technology. So that group technology or GT is the uh, technology which helps in strengthening the batch production mode of fabrication. Where to implement the group technology? So we cannot, what are the best places where we can implement the group technology? So first is plants using traditional batch production and process type layout. As I said earlier, traditional batch production and process type layout if the parts can be grouped into part families. So there is a chance to group the part into part families depending upon the various attributes that we'll be going to discuss in detail. To be very precise, the design attributes and manufacturing attributes. If we can group the parts into part families, then we can implement the group technology. Next is how to implement group technology. So first, since this is a philosophy that similar parts, similar processes can be done similarly, parts can be grouped into some based on their similarities into part families. So how to implement the GT? The group technology, we have to identify the part families. We have to prepare, we have to identify whether there are similarities in the parts or not, and then we have to rearrange the production machines into machine cells. So typically a batch production system employs the process type layout in which the machines are arranged in particular sequence, and which is little bit fixed kind of rigid kind of arrangement. So for that we need to rearrange the production machines, and we need to rearrange the machines into machine cells. Now there are three types of main types of layouts that we can found in today's factory. If we want to divide it, so the line type or product layout, functional layout, and group layout. These are the three types of layouts generally we observe when we talk of today's factory. So let us see one by one what is line type and line type layout. So it involves the arrangement of machines in one line depending on the sequence of operation. So you can see over here the machines are arranged in a sequence one by one. So L, let us presume that L stands for lathe machine, M stands for milling machine, D stands for drilling machine, G stands for grinding machine. So the machines are arranged in a specified particular sequence, and one foreman and the team of workers can work on each line to complete each part. So each part comes over here, raw material comes over here. It is processed according to the machines are placed in the sequence, and the parts goes out. So for this entire line, one foreman is responsible. One foreman and his team is responsible to carry out all the operation. But if the part is having different specification, then we need another production line in which the machines may be arranged in some other sequence, and we have to assign another team of workers to carry out the operation. So it involves the arrangement of machines in one line depending upon the sequence of operation. If the product layout, depending upon the sequence of operation in a product layout, if there is more than one line of production, there are as many lines of machine. So more than, why we require, as I told earlier, more than one line of production, why we require it? Because depending upon the product specification. So it is not mostly viable, feasible that we have to stick to only one kind of product. There must be some variation, some specification changes in various products. So if those changes in specifications happen, we need to install another line of production. So there are as many lines of machine depending upon the product variation or specification. So line layout is used at present in simple process industries, in continuous assembly, and for mass production of the components required in very large quantity. Okay, so it is quite obvious that these since these machines are arranged in some specified sequence, it is fixed, it is quite fixed, and they cannot handle the variation in the uh, products. But since this is fixed kind of layout, we can have one advantage, that we can produce it, we can use the entire line for the mass production in very large quantity. So production volume is quite large in case of line type of layout. Then functional layout. In functional layout, all the machines of the same type are laid out together in the same section under the same foreman. So you can see over here some machine cells in which the machines are laid down into some cells. The common machines, the similar machines are laid down into the cells. So lathe machine, milling machine, grinding machine, and drilling machines. The similar machines of the same types are laid out together in the same section, and each foreman is looking after each machine cell. So each foreman and his team of worker is specialized in one process. So each foreman and the team is specialized in one process. So here we don't need the variation in the expertise of the workers. We need all the four workers which are quite efficient or quite convenient or quite comfortable to work with the lathe machine only, and they are working independently. Whatever the lathe machine related processing is required for the part, that comes onto this section. Whatever the milling machine kind of milling machine fabrication processes required, that comes under this section. Similarly for grinding and drilling. So each of the team is working independently. So this type of layout is based on the process specialization. So, okay, previous one was in the product specialization, and this one is a process specialization. So each foreman is responsible to take care of each of the machine cell. This is what we call as functional layout. An important point to be noted that these functional cells or in functional layout, each of the cell, the workers and the units are working independently. There is no interrelation between each of the machine cell, or what we can say the same functional layout. What is the problem with this? We have to reroute the product depending upon the processing sequence. So sometimes it requires lathe machine, and after that it requires drilling machine, and after that it will require milling machine, and maybe after milling it again, it should go to the lathe machine. So there is a quite routing of the problem product takes place. So that's why the lead time, manufacturing lead time, we call it as it increases considerably because of the material handling, inefficient material handling. Now, what is the third type? It is a group layout. In group layout, each foreman and his team specialize in the production of one list of part and cooperate in the completion of common tasks. So here, each team which is working is specialized in production of one list of part. Okay, so one list of part, whatever the parts, the fabrication of part is divided into some phases, and each team, each machine cell is responsible for carrying out that particular phase. So in a phase one, we require two lathe machine, milling machine, and drilling machine. So whatever the processing needs to be happen on the part, that is done in the first cell. Then the part is sent to the next cell for the phase two fabrication. Similarly for the phase three and phase four. So depending upon the process component specialization, these types of layouts are laid. So one foreman and one team workers complete each of the part. So machines in each group need not to be used in the same sequence. So you can use whatever the machines that are available in your section, that can be used by any sequence. So it is not compulsory, it is not mandatory to use some particular kind of fixed sequence for the machines which are included in the machine cell. Now let us look at the difference between your group functional layout and group layout. So see the difference. So in functional layout, machines are grouped by the process type. Okay, so machines are grouped by their process type. So lathe machines are grouped into one cell. The grinding machines are grouped into one cell. Drilling machines are grouped into one cell. So as I said earlier, there is a quite considerable routing of the problem, quite considerable handling of the part, and that makes this functional layout a quite complicated kind of thing. Instead of that, if you look at the next diagram or the lower diagram, which is of group layout, so machines are grouped based on the component families depending upon the similarities of the product design and manufacturing attribute similarities. So based on that, the parts are the family of machines are created a group, and that's why the material handling or the product handling problem is considerably reduced, or it is quite smoothly handled with the help of your group layout. So you can see the two diagrams, how the how complicated is the first diagram compared to the second one. So that's why the group type of layout is quite acceptable, and it is quite efficient to implement. So now I was talking about group technology and part families and arranging the parts together. So there must be some criteria, so there must be some guidelines, some thumb rules to create the part families. So large manufacturing system can be decomposed into smaller subsystem of part families based on the similarities in design attributes and manufacturing attributes or manufacturing features. So what is the thumb rule? What is the principle? How the part families are grouped together, or how the part families are formed based on the design attributes and manufacturing attributes, or design similarities in design attributes or and similarities in manufacturing attributes. So let us see what are the similarities in design attributes. So design attribute means the parts having similarities in parts configuration. For example, the round parts are forming one part family, and the prismatic parts are forming another part family. Dimensional envelope, length to diameter ratio, if it is a round part. If it is a prismatic part, then length to width ratio or length to thickness ratio, that dimensional envelope can be considered, and based on that, the part families can be formed, or the parts can be grouped together. Then surface integrity, what is the surface roughness, what are the dimensional tolerances offered through that particular part. Based on that also, your part families can be created. Then material type, raw material state, what is the raw material state, whether the raw material part is, it is cast or it is forged or it is bar stock, whatever, or it is a purchase part. Based on that, again you can have uh, group your or create your part families. Now, what are the part manufacturing features? Operations and operation sequences. So what are the, if there are some operations which are common for some of the parts, then those parts can be grouped together. If there is common if similarity in the operation sequence for some of the parts, then it can form a part family or part group. Then batch sizes, if there are common batch sizes, then the parts can be grouped together. If the similar machines can be used for various parts, then the part families can be created. If the similarities in the tools, work holding devices are there, again you can have the part families which can be grouped together. Then processing time is again one of the aspect or one of the feature in the when we consider various manufacturing features. If some parts require the common processing point of processing time or similar processing time, then the parts can be grouped together. So to club up or to recollect it, the parts can be grouped into part families based on the various design attributes and manufacturing attributes. Okay, so we have seen some of the design and manufacturing attributes. Depending upon the similarities in design and manufacturing attributes, the part families can be created. Group technology emphasizes on families based on the similarities in design attributes and manufacturing attributes. Therefore, group technology contributes to the integration of CAD CAM. So some of the, we say that since part families can be created, or it is emphasized that the part families are based on the similarities of in design attributes and manufacturing attributes. So that's why it contributes to the integration of CAD and CAM. So design attributes come under CAD, and manufacturing attributes, if we consider those are coming under CAM, then the group technology is a very good role in the integration of CAD and CAM. So let us see how the part families can be created. What are the methods for identifying the part families? Before that, just look at the picture. These are the design characteristics or design attributes, geometrical features. Based on this, the parts can be created into some similar part families, and these are the process similarities, manufacturing attributes which are similar for the parts. So there are three methods for identifying the part families. First is visual inspection, second one is classification and coding, and third one is your production flow analysis. So you can see that visual inspection is a very common technique, which is very simple one and which is very inexpensive one. Just by merely looking at some of the parts, you can say that the parts can be grouped together. So visual inspection method, let us see, these are few parts which are available with you. So some of the parts are rotational part and some of the parts are prismatic part. So just by merely looking at the parts, you can group the prismatic parts into one family and rotational parts into another family. So it is a very simple technique, but it leads to an incorrect results because we cannot say it requires a quite considerable amount of experience to group the parts into part families. If you look at some parts, by overall looking it may look similar, but if you go for the entire processing of the part, it may take some different routes for different part. So it requires, as I said earlier, it requires a considerable amount of experience to group the parts into part families just by visual experience or visual inspection. And if someone is lacking this kind of experience, then it will lead to incorrect results. Then there are always chances of intervention of the human error, since no software or no technology is involved, no automated process is involved in this, no thumb rules are involved. So that's why there are always a chances that human error may exist in the part families created by the visual inspection method. There is a chance of different judgment by different people because each person is having its own perspective of looking towards some of the things. So each of the person, if two people are there, one person may feel that some of the parts may be grouped into some particular part families, and according to another person, the grouping might be wrong. So that's why different judgments by different people creates a conflict in the visual inspection method. But on the other hand, it is an inexpensive method. It is a least sophisticated method. It is a quick one, and it is also good for the companies having smaller number of parts. If you are dealing with 30, 50 number of parts, then it's okay. But if you are dealing with 1,000 parts, 10,000 parts, then it is very difficult for you or anyone to group the part into part families just by the visual inspection. Second type or second method of grouping the parts into part families is classification and coding. So coding is the process of assigning symbols to the parts. So we assign symbols to some of the parts where the symbols represent design attributes of the part and manufacturing attributes of the part, or both design and manufacturing attribute. So it's a process of assigning symbols which are representing the design attributes and manufacturing attributes of the parts. So that is what we call as coding. The classification is the process of categorization of a set of parts into part families. So if we want to categorize the set of parts into part family depending upon the coding, so that process is called as classification. So a GT code, a group technology code, is a string of characters capturing the information about an atom. So it is a string of characters, it is a combination of characters capturing the information about your design attributes and manufacturing attributes of an atom. So there are three main types of coding system. First one is monocode or hierarchical code. Second one is polycode or chain type structure. And third one is the mixed mode structure, which combines monocode and polycode. Let us see one by one what is monocode, polycode, and mixed code. So in monocode, this is your total part product population. Now, in apart from your total parts, some of the parts are the sheet metal parts. Okay, it requires sheet metal processing, kind of processing. So if the parts are having metal parts, then we assign a number 0 or digit 0 to all those parts. All machine parts which are taking place, all the machining taking place at your end, those machine part can be grouped into some parts, into some families, and we'll assign all those parts a number 1. Then the purchase part, purchase components can be given a number 3, and raw material given a number 9. Then whatever the all machine parts that are with you, so those parts can be subdivided again into rotational machine parts and non-rotational machine part. So again we'll be assigning a number 0 and number 1 to rotational and non-rotational parts respectively. Again we are having some design attributes. Some, if you go into deeper of the rotational part, the design attributes are length to diameter ratio for various limits. And if we consider the non-rotational machine part, we will be considering length to width ratio or length to thickness ratio for a considerable range. So each part must be get some combination of digits depending upon all these things. So these are the design attributes. Then purchase components, raw material, again these are the design attributes. Machine parts is the manufacturing attribute. Sheet metal parts, again it's a manufacturing attribute. So the parts can be given a code depending upon the design and manufacturing attributes. So a monocode is a hierarchical code, provides a large amount of information in a relatively smaller number of digits. So it is useful for storage and retrieval of design related information such as part geometry, material, size, etc. So if we are having one code, if we retrieve that code, and depending upon the sequence of that particular code, not sequence, depending upon the structure of the code or whatever the numbers involved in that particular code, you can easily store and retrieve the information about the part geometry and material size, etc., as and when required. But it is difficult to capture the information on manufacturing sequences in hierarchical manner. So it is applicability, that's why the applicability of this code in manufacturing is rather limited. So that is what we call as monocode. Then polycode, the code symbols are independent of each other. So the codes are not dependent on each other. That's why it is a quite long code, but it gives a quite considerable amount of information, and it is not that complicated at your monocode. So each digit in the specific location of the code describes a unique property of the workpiece. So you are having a particular location fixed for particular property of the workpiece. So that's why it is easy to learn and useful in manufacturing situations where the manufacturing process have to be described. When the manufacturing process, there are common manufacturing attributes needs to be defined. This polycode form a good option. The length of a polycode may become excessive because of its unlimited combinational feature. So each code, each location describes only one feature. So that's why the length of the polycode is excessive, because there are lot of combinations involved, combinations of the features involved. Let us see the polycode, the structure of polycode. So these are the position 1 to 6, 1 to 7. The code having some alphabets or some digits. So what is number 1? So number 1 is assigned for the material. Number 2 is for material shape. 3 is for chemistry. Fourth position is assigned to the production quantity. Fifth position is for surface finish. Tolerances are given the position of 6, and seventh position we are having machine element orientation. Machine element orientation. So as I said earlier in the it is mentioned in the previous slide, each position is assigned and each position defined some attribute. So let us see. So digit 1 to 5, then we are having a class of features and possible values of the digit. So digit number 1. So digit number 1, the class of feature is external shape. Then in external shape, if we go again into deeper, so the shape may be cylindrical without deviation. So at position 1, if the part is having cylindrical without deviation, you can have a number 1. If cylindrical with deviation, you can go for number 2. Possible value of the digit is number 2. Then box-like structure, if there is box-like structure, we go for number 3, and so on. Then digit 2 is assigned to internal shape. So internal shape is there. If there is no internal shape, then we can go for 1. If there is center hole, we can go for 2. If there is blind hole, center hole, we can go for 3, and likewise. Then number 3 is again assigned to number of holes in the part. If it is no hole, then 0, 1 to 2 holes, then 2, 3 to 5 holes, then we can go for 3. Again, what is the type of the hole, whether it is axial cross or axial cross, depending upon that, we can assign a possible values 1, 2, 3, and so on. Again, if we are having the gear teeth, then we can go for the digit number 5, and depending on the type of gear teeth, one or internal spur or external spur or whatever it may be, we can assign the value. So you can see that from the polycode there is a lot of information is extracted and can be stored from a single code, but there is a complexity because lot of combinations are involved in the creation of the polycode. If we take the shape, external shape only, so there are a lot of combinations involved. So that's why the length of the code is excessively long. Then we go for the mix code, which is a very common and which is very popular one. So that mode is one of the popular method is the Optis classification system. So it is a mixed or hybrid coding system. It is developed by Optis Technical University of Aachen in 1970. It is widely used in industry, and it provides a basic framework for understanding the classification and coding process. It can be applied to machine parts, non-machine parts, both form and cast, and purchase part also. So machine parts like manufacturing attributes are also involved. Then form or cast and purchase part, then that means the design attributes are also involved, and it considers both design and manufacturing information. So let us see more about mixed or Optis kind of system, classification system. It is, let me tell you, it is important from exam point of view. They ask you in the exam to write a code. With a, they give the figure, they give the diagram, and you have to write the Optis classification code for that particular system, particular diagram. So it code is again subclassified into form code, supplementary code, and secondary code. So form code gives you uh, the information about your design attributes. The supplementary codes gives you the information about your manufacturing attributes. So form code focused on the geometry, dimension, and features relevant to part design. So form code, the first portion, first phase gives you an idea or information about the design attributes of the product. Supplementary codes gives you the information relevant to manufacturing, such as raw material, tolerances, and surface roughness. Secondary codes are intended to identify the production operation type and the sequence. What is the production operation, and what is the sequence of that can be identified with the help of secondary code. It can be designed by the user firm to serve its own needs. So basic structure of the Optis, digit number 1, it gives you the part shape class, rotational versus non-rotational. Rotational parts are classified by length to diameter ratio, and non-rotational parts by length, width, and the thickness. This I have already told you. Then digit number 2, position 2, gives you an idea or information about external shape features. Various types are distinguished. Third position is for rotational machining. This digit is applied to the internal shape features, example holes or threads on the rotational parts, and general rotational shape features on non-rotational parts. Number 4 is for the plane machine surface, whether they are flats or slots on the outer side. Auxiliary holes, gear teeth, and other features are present, then we can assign the position 5th. Then dimensions, overall size is for number 6. Work material, whether it is steel, cast, aluminum, or whatever it may be, you have to use digit number 7. Original shape of raw material goes to number 8 digit, and accuracy requirement goes to number 9 digit. So that this is how your basic structure, and strictly the position is the particular position is used to describe the particular feature of the part which is under consideration. So digit 1 gives you the part class, whether it is rotational or non-rotational. If it is rotational, then we can use the digits from 0 to 5. If the length to diameter ratio is less than or equal to 0.5, you have to use number 0. Then if it is between 0.5 to 3, you can use number 1. If it is greater than or equal to 3, then it is number 2. Likewise, you can use the various digits for the length to diameter ratio. I mean, not length to diameter, for the rotational part. For non-rotational part, it is based on the length to width or length to thickness ratio. If for the various range, it is 6 to 9 parts, 9 digits can be used. So digit 2 is for main shape, external shape element, main shape for the rotational and non-rotational part. Digit 3 is for rotational machining. Digit 4 is for plane surface machining. Digit 5 is for additional holes or teeth or gears or forming. And the supplementary code 6789 gives you the additional idea about the manufacturing operations and sequence. So this is the form code for digit 1 to 9. We'll be making use of these tables to form a form code for the diagram in the next part. So given the rotational part design below, determine the form code in the OPTIS parts classification and coding system. So this is the part. So number 1, we go for we just by looking at the part, we can see that the part is a rotational one, and that's why we have to use the part class 0 to 5 from the rotational one. Okay, rotational parts we can assign a digit 0 to 1, and then we have to consider the length to diameter ratio. So length to diameter ratio is 1.5 is the length and diameter is 1. So L by D ratio is 1.5. Now we have to check what is the digit we can assign for L by D equal to 0.5. So it falls under 0.5 to 3. So that's why we have to assign number 1. So how we have assigned? Digit 1 is for rotational and non-rotational part. Since the part is rotational 1, we will be going to use the numbers between 0 to 5, and the L by D ratio falls between 0.5 to 3, and the number assigned is number 1. So that's why we'll be using it digit 1 at the place of digit 1. We'll be using number 1. Then number 2, digit 2 is for external shape and external shape element. So external shape is both end step with screw threads on one end. So if you look at this diagram, so the diagram shows that it is stepped at both end. This is one step and this is another step, and on one side there are external screw thread. So let us see where it fits. So external shape with external element. So step to both ends uh, since it is step to both ends, we can use the digit 4, 5, or 6, and we will see again in detail whether there is no shape element, or whether there is a thread, or whether there is a functional group. So instead of apart from this, we are having threads on one side, screw threads. So that's why we can use number 5. Why we are using number 5 at digit 2? Because the external shape is stepped to both ends and there are threads, so that's why we will be using the number 5 over here. Then internal shape, the part contains a through hole. So digit number 1, at digit 3 we'll be using 1 number. So internal shape, internal elements, there is no shape and it is through hole. So that's why we'll be using number 1. Okay. Then we'll be having number 4, plane surface machining. There is no surface machining. I mean, there is no information is given about the surface machining. So there is, we consider it as none. So that's why digit 4 will be using as 0. And there are no auxiliary holes, gear teeth, etc. So that, again, that's why at digit 5 we'll be using number 0. So the form code for this particular part by using Optis system is 15100. Okay. Then next part, see the part again, the part class, it is a rotational part. L by D is 9.6 to 4.8. It is again 0.5 to 3. So that's why we will give the assign the number digit 1. External shape, the part is stepped on one side with the functional groove. So this is a functional groove. So we'll use the second digit, that is 3. So the part is stepped at one end and there is a functional groove. So that's why we'll be using the number 3. Internal shape, the third digit is 1 because there is through hole. That's why we'll be using number 1 as in mentioned in the previous diagram. Plane machine surface. So at the plane machine surface, we'll be using digit 0, which is not because no information is given for the machine surface. And auxiliary holes and gear teeth. So here it is per gear, 4.8 pitch circle diameter is given. So fifth digit is 6 because there are spur gear teeth on the part. So let us see the fifth digit. So spur gear teeth is at number 6. So that's why we'll be using number 6 at the your fifth position. So it is the code for this system is 13106. So 13106 is the form code which gives us the idea about the design attributes for the particular part which is given by the Optis system. The third method is production flow analysis. It is a method of identifying the part families and associated machines, groupings based on the required manufacturing process for the need for the each part. So these are the machines and these are the parts. So we can group the machines similarly into some particular sequence processed based on the manufacturing process that need for the each part. Let us see number 3. So number 3, third part is first processed on C, then it is on E, and then it is on I. So we can group number machine C, E, I into depending upon the sequence of operation of part number 3. Now part number 2 required the processing at E and processing at machine I. So part number 2 is also grouped in CEI machine mode. Similarly, part number 6, which require the processing at C and I. So that is this is how, depending upon the required manufacturing process which are needed for the each part, the production flow analysis system work. So there are 3 methods to group the part families, to form the part families: visual inspection, classification and coding, and production flow analysis. So the selection of the classification and coding system, define your objective, reasons and users, try to get conscious so that the classification and coding system is useful in design, purchasing, manufacturing, quality, etc. It must be robust and expandable. It can be work fine with your existing system, and it must accommodate the unknown future products and applications, which are the potential one. It is easy to get information in and out in a timely manner, and is the coding system is able to handle the present and future product, that is also needs to be considered while selecting your classification and coding system. Whether it is simple and the user interface is quite simple, whether the user can adopt it and can use it with no complaints, that is also taken into consideration. And obviously, what is the cost involved in implementing this classification and coding system, that again needs to taken care of. These are few of the benefits. We'll look into detail. So these are some tangible or intangible benefits. So, engineering design, reduction in new part design, reduction in number of drawings to standardization, reduction of number of similar parts, easy retrieval of similar functional parts, and identification of substitute part. These are the advantages which we got by group technology in engineering design. Then reduction in product floor space is required, because there is a greatly reduced in the production floor space, because we will be using the group type of layout in which the machines are grouped together upon the product specification, and that's why there is a less routing of the part, less material handling effort are required in group technology. The standardization of equipments can happen, and implementation of cellular manufacturing systems can be done, which again can be used as a flexible manufacturing system. There is a significant reduction in the upfront cost incurred in the release of new parts for the manufacturing. The process planning is also greatly improved by the reduction in setup time and production type. Alternative routing leading to the improved part routing, we can have always a chance to route the part by some alternate method if there is some failure in the regular route. Reduction in the number of machining operations and numerical control programming time. Production control is again there. There is a reduced work in process inventory, easy identification of bottlenecks, improve material flow and reduce warehousing cost, faster response to schedule changes, improve usage of jigs and fixtures, pallets, tools and material handling, and manufacturing equipment. Quality is also greatly increased by reducing the number of defects, leading to the reduced inspection efforts, reduced scrap generation, better output quality, increased accountability of operator and supervisors responsible for quality production, and making it easier to implement the total quality control concept. If you talk of purchasing, the coding of purchase part leading to the standardization rule for purchasing, we can lay down some standardized rule. Economics of purchasing is possible because accurate knowledge of the raw material is acquired and retrieved, reduced number of parts and raw material, and simplified vendor evaluation procedure leading to the just-in-time purchasing. So we can give a better customer service by accurate and faster cost estimate. We can have efficient spare part management leading to better customer service and lower lead time. So this is what we call as group technology, and it is the various benefits of group technology. So that's all for today's session. You can post your attendance in the chat box and you can leave the session. Thank you.
Thank you, sir.